All right, ladies and gentlemen, welcome back to our second last topic of the science 10 year, which is crazy. Today, what we're going to be doing is talking about a second kind of type of energy. So, last time we talked all about potential energy and how it's energy that's stored in things, that it's energy that's not being used. So, today, we're going to talk about energy that is getting used. So this is a huge category of types of energy, and it all boils down to what we call kinetic energy, right? So kinetic energy is the energy that moving things have. So it is the energy of motion. Anything that's moving has kinetic energy, and it's the kinetic energy that is making it move, all right? So it's found in anything that moves. A couple things about kinetic energy, because it is a type of energy, just like everything else we've seen, we measure it in joules, all right? It is the faster something is moving, the more kinetic energy it has. So if anything that's moving faster than something else has more kinetic energy, right? And also the mass of the object that's moving, it plays a factor in the amount of kinetic energy it has. So if something that weighs more, has more mass to it, that means it is going to also have more kinetic energy because it took more energy to get that thing to start moving, all right? So if I have two objects traveling at the same speed and one of them is heavier than the other, then the heavier one will have more kinetic energy because it would have taken more work to get that object to that speed, all right? There are specific types of kinetic energy. So we talked about this last time. So electricity is the movement of electrons, all right? Heat energy is just the energy that moving particles have as they kind of vibrate together and kind of rub against each other. And then sound energy is kinetic energy that moving airwaves have. And light energy is just kinetic energy that photons have, all right? So one thing I want to clarify here, because this came up in our conversation that we had in our virtual class last Thursday, is that kinetic energy is a big, broad category. It doesn't matter what the thing is. If it's moving, it has kinetic energy. These four down here are just specific objects moving that have that energy. So electricity is moving electrons. Heat is moving particles. Sound is moving airwaves. Light is moving photons, okay? But anything moving has kinetic energy, like a car, whatever it happens to be, right? Now, kinetic energy is a fairly easy concept to understand. With potential energy, there's a lot more in terms of how we store that energy, whether it's in a chemical bond or in the nucleus of the atom, or whether it's because something is high off the ground or stretched out. Kinetic energy is pretty basic. If something is moving, it has kinetic energy. There's nothing more to it than that, which is nice. So theoretically, kinetic energy is easier to understand, but I will say mathematically, kinetic energy has a bit of a trickier formula for us to work with. So what we're going to do today is take a look at the formula, talk about and break it down. Then we'll do 3 practice problems for the 3 different arrangements the formula can have. And then the rest of this time will be for you guys to kind of practice the kinetic energy questions in your booklets. All right? Okay, so here's our formula for kinetic energy, all right? And it seems complicated because it has 2 things in it that we have not seen yet in science, in physics 10. You've seen this in math class, so nothing terribly complicated, but it might throw off how you approach the question. So I want to break this formula down a little bit more than I normally do. So our formula is that our kinetic energy, which we just use E with a little k, okay, is equal to 1/2 of the object's mass times its velocity squared, all right? So the 2 things in this formula that complicate it, that make it seem harder than it is this 1/2 here and this squared velocity, okay? So I just want to talk about this briefly. Number one, I hate this formula, okay? And I hate it because this is the way it's shown to you in your data booklet. If you take Physics 20, this is how they're going to show it to you there as well. But we can actually write this in a simpler form that I think is easier for students to understand, which is that kinetic energy, EK, is equal to mass times velocity squared divided by 2. And what I find is by making this subtle change from this 1/2 to this divided by 2, I find students have an easier time approaching this. It ends up being the same mathematically. Multiplying something by 1/2 is the same as dividing it by 2. But I find that fractions tend to throw students off, and it makes them kind of do weird things, especially when you start rearranging formulas. So I will, from this point forward, always write the formula this way, okay? Your data booklet has it this way. That's all there is to it. That's fine. But you are welcome to rewrite or write it like this. I just find this easier to work with, Okay. The other trick to this, and it's not hard because you guys know how to square a number, you know how to use your calculator. I'm not worried about that, but I find that this velocity squared really throws students off because when you put numbers into the formula, you might put in something like, okay, this thing is going 36 meters per second, and then I have to square that. And I find that students put that square like this, and then suddenly you think it's acceleration, and you kind of get blind to the fact that you need to actually square the number, not the unit. So when you're doing this calculation, just make sure that when you're approaching these problems that you always remember that you need to square whatever the velocity is. You don't want to do this here. Okay, I'm just going to erase that so you don't get too mixed up on it. All right. So again, formula is EK, kinetic energy, is equal to, which is measured in joules, is equal to our mass in kilograms divided by our speed or velocity. It doesn't really matter because, again, we don't have direction when it comes to energy, so we should never have negative energy, okay? So we have our meters, our speed squared, and then we divide that by 2, right? So let's take a look at 3 questions. There's only 3 ways to rearrange this formula. So we're going to do one where we solve for kinetic energy, one where we solve for mass, and one where we solve for speed. All right, and these are going to be on pages 10 and 11 of your booklet. We're going to jump around a little bit, so I'll make sure I point out to you exactly what question it is that we're doing. All right, so this first one here is going to be our most basic type of question. This is on page 10 of your booklet. It's question number 1. All right, so it says, Amy is running home from school. Her mass is 48 kilograms. It should say and, I did miss typo there. So, and she is traveling at 6 meters per second. Calculate her kinetic energy. So we're going to use our formula that we just talked about. So we're going to use EK is equal to mass times velocity squared divided by 2. We don't know our EK here. We know her mass is 48 kilograms. And we know her velocity is 6 meters per second, right? So all we're going to do is take what we're given in the question and plug it into the formula. So our kinetic energy is going to equal 48 kilograms times 6 meters per second squared, okay? And I think it's really important to use brackets here just so you remember to actually square that number. It'll stop you from making that mistake where you think you're looking at an acceleration question. Okay, and then we're just going to divide that by 2. I'm going to throw all that in my calculator. I'm going to go 6 squared, which is 36, times 48, and then I'm going to divide that by 2. And when I get that, I get 864 joules. Okay, as usual, I have to check my significant digits. I have 3 significant digits in my answer, but in my question, both of these had 2 significant digits. So I'm going to have to round that, and because I'm getting rid of a whole number, I'm going to have to use scientific notation. So my answer here should be 8.6 times 10 to the power of 2 joules. All right, so not too bad. As long as you remember to square the number, you should be fine. Let's take a look at what happens now when we have to rearrange the formula. All right, so in this next one, we say that if the kinetic energy of a basketball is 100 joules and it has a mass of 2 kilograms, what is the speed of the ball? All right, so this time we know the EK is 100 joules. We know that the mass is 2 kilograms, okay? And this time we're trying to find the speed, okay? I will tell you right now that this is the hardest one to rearrange the formula for. So we're going to go through it step by step in how we rearrange the formula, and then we'll come back and actually solve the problem, all right? So our formula, as always, is EK equals mv squared divided by 2, okay? But I'm trying to find v, okay? I want to get v by itself. So as usual, I have to undo everything that I'm doing to v, okay? So the first trick in this formula, whenever you're rearranging this, is you got to get rid of the 2. You got to get it out from underneath the division sign first. So what we're going to do in our first step here is we're going to multiply both sides of this equation by 2. That gets these 2's over here to cancel out. And so when I rewrite my equation, now I have 2ek equals mv squared. Okay, now this becomes a little bit more approachable. Okay, so again, I'm trying to get v by itself. I want to keep undoing everything that's happening to v. So the next thing I want to get rid of is actually the m. okay, by our rules of bed mass, we actually want to get rid of the exponent last, because when we're doing algebra, we have to follow reverse order of operations, okay? So we're going to get rid of this m here, and we'll deal with the squared after that. So we're going to take this equation, and we're going to divide both sides by m, okay? That gets my m's over here to cancel out. And so now what I'm left with, sorry, is 2ek over m equals v squared. Okay, I'm not quite done because I don't want v squared. I want just v by itself. I want to get rid of this square. So we have to do the opposite. The opposite of squaring a number is, hopefully you know this from math, taking the square root of that number. Okay, so I'm going to take the square root of this side of the equation. That's going to cancel out the square root and the square. But I also have to take the square root of this side of the equation. Okay, the whole thing. So what I end up with here, and I'm just going to zoom out a little bit just to give myself some space. When I rewrite this properly, my new formula solving for v is going to be v is equal to the square root of 2ek over m. Okay, so that is now my formula that we're going to use to solve this problem. And it seems tricky, but an easier way to remember it is that you just have to go 2 times whatever the kinetic energy is, divided by mass of that object, and then just take the square root after that. Okay, so we're going to plug our numbers in here into that formula. So we're going to say our velocity is equal to the square root of 2 times 100 joules divided by 2 kilograms. And I should actually use the correct significant digits in there, 2.0 kilograms. Okay. What's nice about this one is the 2's kind of cancel out. So what I'm going to do here in my calculator is go 2 times 100 divided by 2. So 2 times 100 divided by 2 is just going to be 100. So then I just have to take the square root of 100. I'm not going to worry about the unit is there. Okay. And the square root of 100, you guys should know, is 10. And because we're looking for speed, we're looking for meters per second. We have the correct number of significant digits because our mass had 2.0 kilograms, 2 digits. This has 2 digits as well, so we're done. We don't need a direction because energy never has direction with it. All right, so this is our last question that we're going to do as an example. This one's on page 11. It's question number 9. I just wanted to make sure we had one where you had to calculate the mass as well, just so I could show you how to rearrange that formula. All right. So this one here, it asks, what is the mass of an object moving at 3.5 meters per second and which has a kinetic energy of 78 joules? Perfect. So we know our EK is 78 joules. We don't know our mass. That's what we're trying to find. And we know that our velocity is 3.5 meters per second. All right, so just like last time, we're going to rearrange our formula to solve for mass, and then we'll put in the numbers. All right, so our formula, as always, is EK equals mv squared divided by 2. All right, we're going to rearrange this one to solve for mass. Okay, so we're going to actually follow the same first step that we followed last time. The first thing we have to do is get rid of this 2. Okay, so we're going to multiply both sides of the equation by 2. All right, and so I get to that same spot I was in last time, which is now 2ek equals mv squared. That is not a 2. There we go. And I should show that we canceled these guys out, so we get rid of those 2's. Now what we're going to do is get rid of that v squared. So we have to divide both sides of our equation by v squared to get that to cancel out. Okay. These guys over here cancel out, and what I get left with is 2ek over v squared is equal to my mass. All right, so that's the formula we're going to use. I'm just going to zoom out again just so I can give myself some space to write. So we're going to solve the question using this formula. So our mass is 2ek over v squared. All right. Plugging our numbers in, our kinetic energy is 78 joules. And our velocity was 3.5 meters per second, which I then square. All right. When I plug that in my calculator and go 2 times 78 divided by 3.5 squared, what I get as an answer is 12.7 kilograms. And I have to double check my significant digits. This has 3 digits. Both of my original numbers had 2. So my final answer is going to be rounded to 13 kilograms. Perfect. That's it. So just to sum up a little bit. So the big formula we learned today is this guy here. EK equals mv squared divided by 2. If you prefer to write it as EK equals 1/2 mv squared, that's totally fine. It doesn't change how we rearrange the question at all. The other ways we can rearrange it, if we want to find mass, we go 2 times kinetic energy divided by v squared. All right? If we want to find velocity, this one's a little trickier. We have to go 2 times kinetic energy divided by mass, and then we take the square root of that. So I always remember that when I rearrange this formula, 2ek always ends up on top, right? And then I divide by the other unit. If the other unit is velocity, I have to remember to square it. If the other unit is mass, I need to remember to take the square root of my final answer. All right, so just a couple little tricks for you. At this point, you guys should do the practice questions on page 10 and 11 of your data booklet. And then there is a boot camp as well if you want extra practice with kinetic energy. This is a tougher formula to use, so I highly recommend doing all the practice work just so you get the hang of how to manipulate it, when to use which formula, etc., etc. And then just the last thing I wanted to talk about today is that we've done a lot of formulas since we switched to booklet number 3. You'll find that the math is fairly easy, or the theoretical piece of things is easy in this booklet compared to acceleration for sure, where we had all that graphing. The one trick with this section is that there are a lot of formulas. We still have 2 more formulas to go. So I just want to take a second to sum up all the formulas we've learned in this booklet. So number 1, you need to know how to calculate force, which is always mass times acceleration. Or if we're talking about something's weight or the force of gravity, we use mass times the pull of gravity, 9.81 meters per second squared. Right? Remember that force is always measured in newtons, and force should have a direction because acceleration has a direction. All right? The acceleration, the direction of the force and the acceleration are always the same, which is why direction matters. Okay? Then we get into our energy calculations. We've done 3 energy calculations so far. We did work. Remember that work is energy. It's how much energy that you give to something in order to make it start moving, typically. All right? So it's not so much a type of energy as it is just how much energy did you transfer. So it's still measured in joules. Energy never has direction to it, though. Either you have energy or you don't. You don't have energy to the east, as an example. It's always equal to the force applied to that object multiplied by how far it moved. Okay. Then we have our 2 specific energy calculations. We have potential energy, I should say specifically gravitational potential energy, which is energy that stuff has just based on how far off the ground it is. That's equal to the object's mass times gravity, 9.81, times the height of that object. And then we have kinetic energy, the energy that moving things have. We can figure that out by using either of the 2 formulas. They're actually the same, just a slight difference. So kinetic energy is equal to our mass, the object's mass, times its velocity squared divided by 2. Or if you prefer to use 1/2 mv squared, that's totally fine. That's what's given to you in your book. Hopefully that helps clear things up a little bit. There are a lot of formulas here. You do need to know how to rearrange them. Please make sure you're doing the practice work, and I will talk to you guys about this stuff on Tuesday.